In the previous class, this is where we stopped. We were focusing on protocol. Before that, we were focusing on components of SD-WAN, and we were focusing on OMP in much detail. And then we also saw how the devices get authenticated. There's a zero trust principle. That's the way they are authenticated. Zero trust principle. I have seen this in even in real world. If you go to a company like Cisco, not only Cisco, uh, almost every company, the security guy in the gate, he will have zero trust principle. He may know your face very well. You may be repeatedly going to that office, but still, every time he wants to check your ID, he will not simply allow you inside. If you don't take an ID on that particular day, he won't allow you. He knows that you are an employee, but he don't again trust. He want to have that evidence in your hand to show that you belong to this place now. Likewise, every device, it may be vSmart or WAN Edge, repeating again. Not only WAN Edge need to get authenticated, even vSmart needs authentication. So every device gets authenticated with a certificate and with a whitelist model. This is where we stopped. And now we are getting into another important portion of SD-WAN called segmentation. See, the segmentation is not new. VLAN is a segmentation. You will agree with me. You take layer 2 and you slice it. VRF is a segmentation in layer 3. So you got an idea what is segmentation. We'll go deep into segmentation and we'll see what segmentation means in SD-WAN. And also the protocols of SD-WAN, we'll do a recap. We'll see how the protocols of SD-WAN like OMP and the routing protocols for each segment like OSPF, BGP, how they all contribute here. We'll be seeing that. We'll also see OMP graceful restart, what it means. And we'll also talk about the traffic engineering using OMP preference. First is segmentation. So the segmentation gives us the ability to divide the network into small segments. It creates the portion of network. So it takes a big network and cuts into multiple portions. And each portion of this network is separate, independent from each other, separate from one another. Now, this separation can be physical or it can be a logical separation. When we talk about VLAN, it's a logical separation. It's a logical layer 2 separation. Physical separation or physical segmentation means what? We provide a separate device, we provide a separate link wire, the physical wire. So that is also another segmentation or separation. Logical separation, example VLAN. VRF is also a segmentation or separation at layer 3. None of us are new to VRF in our class. No, all of you have gone through MPLS layer 3 VPN. The knowledge of MPLS layer 3 VPN is very important to understand today's class. Fine. So VLANs provides a logical separation in layer 2. VRF instance provide separation in layer 3. See, if you have done the layer 3 VPN service provider side, we used to map layer 2 VLAN into layer 3 VRF instance. We used to map layer 2 VLANs into layer 3 VRF instance. But you should keep one thing in mind. Every VRF has a separate control plane. So all those layer 2 now becomes a layer 3. When I map layer 2 VLAN into layer 3 VRF, I'm extending the layer 2 separation via layer 3 separation. Because every VRF has got separate routing table, separate control plane. You might have heard about VRF Lite. What is VRF Lite? See, when you do layer 3 MPLS VPN, all VRF configurations are done only on provider edge router, not on every hop by hop. But if you don't have the tunneling concepts, if you don't have that overlay, if you don't have that layer 3 VPN, what you would have done, what you should have done to have separation, you need to go to every single hop by hop basis. You would have configured VRF. You should have configured routing protocol for every VRF on every router. That is what VRF Lite is. VRF Lite is not layer 3 VPN. VRF Lite is going to every single router, creating the same VRF and allocating interface into VRF on every single router, every hop, running a routing protocol in it, a separate routing protocol for each VRF, hop by hop basis. So every VRF will have a separate routing protocol, a separate neighbor relationship. The problem with this is it is going to hamper your processor. It is going to hamper your routing performance. Why? In every router you have multiple routing instance called VRF. Each routing instance have got a dedicated routing protocol, routing tables. Sorry, routing table, separate routing protocol, a dedicated interface map to it, and every protocol forms adjacency with the neighbor. So a lot of hello packets go. Definitely, the utilization of the processor is going high. The processor is going to. That is why we use XR kind of devices. iOS XR means ASR 9000 series devices. But you cannot afford buying 9000 series XR throughout the topology. See, if you don't have MPLS layer 3 VPN, you need to buy only XR router, only ASR 9000 or something bigger than that, like ISR or CSR, which is very costly. So the good news is we don't really do hop by hop. We came up with the idea of forming tunnel between the PE routers so that you no need to configure VRFs on every single hop. You no need to do segmentation on every single hop. We do only on the PE routers. We call it as MPLS layer 3 VPN. So what we do is we define this is the one. We define the segmentation policy only on the edge routers. We call it as provider edge router. See, I'm not into SD-WAN yet. I'm trying to refresh the MPLS, which is going to be mapped to SD-WAN. So we are trying to recall what we know about MPLS layer 3 VPN. So all the segmentation policy like VRFs, mapping VLANs to VRF, everything happens where? On the provider edge, PE router. Not on every data plane points or not on every hops. So MPLS based VPNs is also a very nice example for segmentation, where we write segmentation policy at edge on the provider network. So this enables a better segmentation which overcomes the hop by hop configuration. So now what we can do is we can provide the VRFs to different business units. We can logically divide based on the business units. And that you do only on the PE route. You don't need to do it on every single route. I have 5 customers, I create 5 VRFs only on the PE router, not on every provider node. So with this, technology, layer 3 VPN, you can have any type of topology you want. If you want to have a hub and spoke, you remember, you can have a hub and spoke with route reflector on the hub. You can have partial mesh or any-to-any connectivity is possible. Now coming to segment, SD-WAN. So Cisco SD-WAN also performs segmentation at the edge level only. Only on the PE router, only on the WAN edge routers, the segmentation is done. And this information, the segmentation information is carried across the SD-WAN network with the help of OMP. So with the help of OMP, the segmentation information of one WAN edge is carried across the SD-WAN network. In a field called information field in OMP. There's a field in OMP header called, you know what is OMP, no? Overlay Management Protocol, which speaks to vSmart. So in the information field, the segmentation information of each WAN edge is carried. So in SD-WAN, VPN segmentation is same like VRF in MPLS. Repeating again. In SD-WAN, we don't call it as VRF. We call it as VPN. VPN provides segmentation, same like VRFs. So in Cisco SD-WAN term, a VPN represents a network segment, a VRF. We don't call it as VRF, we call it as VPN. So this VPN information of every WAN edge is carried in the information field of OMP. That information will be distributed to all other edges with the help of vSmart. See, in SD-WAN there will be many VPNs, many VPNs, more than 65,000 VPNs you can have. So what does it mean? You can have up to 65,000 network segments. Today our focus is on segments. I just explained you what is segment. You can imagine like you can have 65,000 MPLS layer 3 VPN. $65,000 VRFs. So many VPNs in SD-WAN solution we use. So VPN is isolated from one another. Every VPN has got its own forwarding table. You can have one VPN for corporate traffic, one VPN for guest traffic, one VPN for maybe administration traffic. Various departments you got, various type of traffic you got. So you can assign different VPN for each department. And one VPN is isolated from the other. They have their own forwarding table. They have their own control and data plane. Every VPN will have its own routing information database.
They're not audible.
So what we have seen is in SD-WAN, every VPN is like a VRF. And one VRF is totally isolated from the other one. And it is on the WAN edge router, we have these VPNs. And you all know about VRF, no? What? Routes from one VRF cannot be seen in the other VRF. Means they don't get leaked. There is no connection inside these two separate control plane. Means the routing table of VRF 1 is different, VRF 2 is same way. VPNs are completely isolated from each other. No information is leaked in between VPNs. And VPN has got its own routing table. So I'm replacing the word VRF with VPN. That's all. Here we call it as VPN only. So we can have multiple default routes. Listen. We can have multiple default routes on the WAN edge router. So you got different VPNs in the WAN edge router pointing towards the ISP, the transport. Some VPN may be pointing towards the MPLS, some may be pointing towards the internet, So you can now have multiple default routes. Usually default route, how many you will have in a normal router when there is no VRF? Only one. Can you have more than one default route? No possibility. Not possible. That doesn't even make sense. The statement itself is wrong. Having default route more than one. Default means what? Only one. By default, I'll use this bike. What does it mean? Uh, I'll always use this bike. Only when that has got problem, I'll look for the other one. That's the meaning of default route. When there is no route in the routing table, I use this exit. But now we have different VPN table, means routing table for each VPN, separate routing table. So now on the WAN edge, I just want you to imagine, WAN edges are in different continents. You have office in different various continents, and you want to communicate between your office, which are in different continents. And you got MPLS connection, you got broadband connection, you got internet connection. You want to make use of these transports, the underlays, and create an overlay called SD-WAN. So you got different VRF, means different VPNs, and each VPN will have a separate default route. You don't need to learn the entire world's network. You just learn default route. You have only a default route for each VPN. Okay, now this WAN edge router has got these two portions, two main portions. It has got WAN side and it has got LAN side. WAN side is what transport VPN is. WAN side is what? WAN means what? The connection to MPLS, the connection to internet. So the WAN side, we call it as transport VPN. The WAN side is where SD-WAN fabric is. Do we have a LAN on the WAN side? No. We have the SD-WAN fabric, the overlay on top of the transports. So we reach to the other components of SD-WAN through this WAN side. We reach to the other components like what? Like vSmart, vBond, or the other sites using the WAN side of our WAN edge. The LAN side is the service side, where we are connected to the corporate internal network, our LAN side, the customer LAN or whatever, the corporate internal network. That is what LAN side is. So anything resides on the WAN segment, we call it as transport VPN. Anything that resides in the LAN side, we call it as service VPN. Listen, we have here two types of VPNs. The VPNs that are responsible for bringing up the SD-WAN overlay is a transport VPN. The VPN that takes the customer LAN traffic from one site to the other site over the transport VPN is the service VPN. So service VPN depends on the transport VPN. Transport VPN is the responsible is the one which takes responsibility of providing you the reachability between the sites. Service VPN is the one which is taking the traffic of each department from one side to another without getting mixed. For each department, you might have given separate service VPN. And when they go through the SD-WAN tunnel to the remote edge from one continent to the other continent, they don't get mixed. I know you MP-less people are trying to map this to the route targets. I appreciate that. Similar to that, but we don't use route target here. We do use some colorings. I'll talk about that. You also know about color. We learn what color means. T-log color. So that is how we are going to choose the path. It's the color, like a route target. Now, let's not get into that area now. We have much more to cover before that. So, anything resides in the WAN side is termed as transport VPN. Anything resides in your LAN side is the service VPN. Now, how do you know this? That depends on the number. You see, we have a special VPN called VPN 0. And this is only assigned to transport VPN. VPN number 0. So we got VPN 0, a reservation, like area 0, no? Area 0 in OSPF. 0 is backbone. Here, VPN 0 is also similar to that. What is the backbone for us here? The transport. The service provider network which provides the underlay reachability between the sites. So there is a VPN number called 0, which is assigned to transport VPN. This is like a reserved VLAN. Only for what? For the management to bring up the overlay. If you are from VMware background, you might have seen some VLANs reserved for VMware communication between the vCenter and the vSphere clients, like VLAN 4, infra VLAN. So those VLAN numbers you should not use. They are only for the bringing up of the VMware network. Likewise, to bring up the SD-WAN overlay, we have got a VPN 0 that is given as a transport VPN, reserved as a transport VPN. So VPN on the service side will contain the interface that connects to the local network. See, on the transport side, it is connecting to MPLS or internet or broadband, whatever you have from the ISP. Whereas on the service side, we contain the interfaces that are connected to the LAN, your local site network. Now, VPNs can also be enabled with the features such as OSPF, BGP, VRRP, QoS, traffic shaping, or traffic policing. So you can have these features in VPN. In each VPN, you can have one VPN you may be running OSPF, or maybe one VPN you may be running OSPF with VRRP because you got multiple WAN edges. You may have different QoS service for different VPN traffics. You may have BGP relationship for one particular VPN. So VPNs can be enabled with features like this. Now, the VPN identifier is a 4-byte integer, 4 bytes, 32 bits, no? 4 byte. It's a 4-byte integer with a value that starts from 0 to 65530. Only this much is what given for VPN ID. Even though it is 4 byte, you can see here only like 16-bit given. So VPN is a 4-byte integer with a value ranging from 0 to 655, not 36, 65530 only. If you take 16-bit, it will go up to 65536. But here, you cannot use more than 65530. So, as I told you, there are VPNs reserved. One of the VPN is VPN 0, which is given to transport VPN. And you know what is transport VPN? The VPN that is towards the ISP, towards the SD-WAN fabric. And the other one is a management VPN. So in SD-WAN devices, 2 VPNs are present by default. Even on the controller, not only on SD-WAN edge, even on the controllers, you will have these 2 VPNs, like controllers like vSmart. They also have this reservation, VPN 0 and VPN 512. These two numbers, 0 and 512 VPN, you cannot use. They're already created and it will be there by default. And VPN 0, as I said, it is for the transport. OMP will be using this. We'll talk about that in detail in a few minutes. The 512 is for the management. Now, both these VPNs have got different roles. On WAN edge, interfaces in VPN 0 are connected to the transport network like MPLS and internet. That's why we call it as transport VPN. VPN 0 is known as transport VPN. You may have multiple transports. The interface that you connect to this VPN 0, see, if you can't understand, you need to just interchange VPN, the word VPN with VRF. You can assign multiple interfaces to VRF, no? Like you can assign multiple interfaces to VPN 0. One interface may be MPLS, one interface may be internet. So you can have multiple transport interfaces for the same transport VPN. So only those interfaces that you make as a member of VPN 0, please make this point very clearly, understand this very clearly. Those interfaces that you put as a member of VPN 0 only can be used to create the control and data plane for those overlay tunnels. So the VPN number 0 is very important. Only using those interfaces that are member of VPN 0, the SD-WAN overlay will come up, will be forming channel. Now, those transport interfaces, which is now taking different departments traffic, like corporate network, uh, different prefixes. So all this that are connected to the WAN edge routers, all these transport interfaces or the T-locks. See, for different department, you want to provide different transport. But all the transports are kept inside where? VPN 0. So it is only one VPN which has got MPLS connection, internet connection, all. Then how do you say that for department 1 I want MPLS connection over SD-WAN? For department 2 I want internet connection over SD-WAN. It is the T-log. It is the T-log that makes the separation inside this VPN 0. Like you have a route distinguisher separating the traffic, like you have route distinguisher in MPLS layer 3 VPN telling that this routes are coming from customer A, that route is from customer B. That is why we call it as route distinguisher. Likewise, T-log also provides a route distinguisher experience in SD-WAN. Even though we have multiple service VPN using this transport VPN, the gateways, the next hops are not going to be same over the SD-WAN tunnel. Those things are kept separate with the help of T-log, and VPN 0 carries this T-log information. And this separation also ensures that the transport network cannot reach the service network by default, because they're all different VPN. Service uses VPN 0, management uses 512. Services will have different VPNs. You may have a VPN called 10, 20, 30. So by default, the transport network cannot reach service network. This is also what? Segmentation. This is what the VPNs, are the one which provides you segmentation, isolation. So you don't need to do any big configurations like route target, route distinguisher. You don't need to do those big advanced configurations that we used to do in our MPLS layer 3 VPN or segment routing in traditional networks. Without taking those pains, you can still have multiple VPNs between sites. Now, VPN 0 is specialized to bring up the WAN network to establish TLOGs to TLOGs connectivity. What does it mean, TLOGs to TLOGs? WAN edge to WAN edge. Between WAN edges, you may have multiple connection policy depending on the traffic that is coming in. If traffic is coming in from department 1 of site 1, going to department 1 of site 2, you may prefer MPLS. From between the same site, if it is coming from department 5, you may like to take a broadband connection. So you have different TLOGs for department 1 and department 5. There's a different next hop address. So different TLOGs. These services are provided by this service VPN called, transport VPN called VPN 0. So it is VPN 0, the one which brings up the WAN network to establish TLOG to TLOG connectivity. So within a VPN, you may have a static route or a default route or a dynamic routing protocol. To be configured inside of this VPN in order to learn those next hop. So for the TLOG, you need next hop. For each VPN, the TLOG needs to provide next hop. This next hop can be learned via can be configured via static or default route or dynamic routing protocol. So this routing information, this enables the control plane to establish between the components, between the WAN edges, and the data plane is IPsec. You know about, right, SD-WAN, IPsec. And the data plane IPsec tunnel to connect to the remote WAN edge router. A secure DTLS-TLS connection to the vSmart, also between the vSmarts, are initiated from VPN 0 only. So we are talking about the segment called VPN 0. The role of VPN 0, first point we saw is it provides the TLOG to TLOG connectivity. Secondly, now what we are seeing is the secure DTLS-TLS connection between the controllers and the WAN edges are initiated using this VPN 0. So every interface in VPN 0 must have an IP address. And now we can have multiple tunnels configured for with different colors, different encapsulations for WAN transport. One may be segment routing, one may be MPLS, one may be internet, one may be broadband. This is what called as colors. So what we need to do is we need to configure VPN 0 to carry the control traffic. Without this configuration, the control plane of SD-WAN will not be able to establish, meaning you have to write a static route or a default route or a routing protocol. Fine. This is all about the transport VPN. The transport VPN. Now the management port is like a out-of-band management. You know what we do in the real world? We create a VLAN. Let's say VLAN 555. This is for management. So all over the office, the management port of every routers and switches we connect to 555 so that you can manage. You can telnet or SSH from a management PC. Likewise, to manage all this SD-WAN components, the management ports are assigned to this VPN called VPN 512. Yeah, 512. VPN 512 is for management. So it is only for management, okay? No other purpose. You can SSH to a controller. So this is only for out of band connectivity. What is out of band connectivity? Meaning they are totally separate from other traffics. This is because it's a VPN, no? So 512 is a reserved VPN number for management ports. This VPN is completely isolated, and this VPN has got nothing to do with OMP because it's only for management, no? This has got nothing to do with OMP. So this VPN is, as I said, local to the LAN, just for management. It's same like what you have in a normal traditional network, the management VPN. And this VPN is not carried across the overlay network. It is local. This VPN is not carried across the overlay network. So we have VPN 0, VPN 512, and all other VPN numbers other than 0 and 512 are used to carry data traffic across the SD-WAN overlay network. So all those VPNs other than the 0 and 512, what they are called as service VPNs. So VPN starting from 1 to 511 and 513 to 655 30. All these numbers are for us to use from the LAN to LAN traffic. And these VPN numbers are called as service VPNs.